Okay, we're going to take another look at 10.1, the parabola section, this time looking at some of the questions my math lab answers, or asks. And I found two main sections. I'm looking at some study plan practice right here. And so the first type asks me to write the equation of a parabola that satisfies the given information. And so this one gives us some information about the focus and the directrix. So the focus is 9, 7, and the directrix is x equals -10. Okay, so the first thing I notice about this one is that we have a sideways parabola since we have a vertical directrix, and then our focus is up here at 9, 10, and so my parabola is going to be something that goes between them. So I'm not sure if I drew it to scale or not yet, but I need to figure out, excuse me, where my vertex is. Now, I do know that the vertex and the focus are going to be equidistant from each other. So if I find the center between the two of them, I'll be able to find the x-coordinate of the vertex. So if I subtract 9 minus -10, or add up 9 and 10 and average them, I can find what the distance between them is. So let's call this like d for distance right there. It's going to equal this d for distance. And so that distance is going to be 9 minus -10/2, or 9 plus 10/2. So 19/2, which is 9.5. Okay, so 9.5 is that distance. So I have to be 9.5 away from -10 and 9.5 away from 9. So that's actually going to give me a -1/2 for my x-coordinate, right? If I take -10 plus 9.5, it gives me -0.5. And if I take 9 and I subtract 9.5, again, -0.5. So this point right here is going to have -0.5 as its x-coordinate. All right, so for my vertex, it's going to be -0.5, 7, because I know that I already had a y value of 7 that wasn't going to change from the focus, so I already knew the y coordinate. Okay, so from that vertex, we have the h value and the k value. The h value is -0.5, the k value is 7. And then we need to know the p value. So the p value is the amount that we add on. So it's actually, I could have called it p instead of d. I call it d for distance. That's our p value right there. So maybe I should call it p right here instead of d. I just use d for distance. It really is the p value because that's the distance between the focus, the directrix, and the vertex. So our p value is the 9.5. We already found it. All right. So the equation for this should be, it's going to have the y squared because we're a sideways parabola. So y minus the y coordinate of the vertex, 7, squared, equals 4 times p, 9.5, times x minus -0.5. All right, I'm going to simplify this before I try typing it in. One of the things is that 9.5 is, again, 19/2, so I can, I wonder how it wants us to type it. I don't know how much simplification it wants us to do, but I'm going to assume it's going to want me to reduce it, make it pretty. So y minus 7 squared equals, and so this would be, what is 4 times 19/2, or 4 times 9.5? So that gives me 38. And then this is going to be x plus 1/2. Again, I don't know for sure if it's going to allow me to type in the half, so let's find out. We'll just try typing in a couple times. It might want me to distribute the 38, so I don't have a fraction. So y minus 7, there's a lot of ways to write it. Squared equals 38, doesn't say integers or anything, so let's try x plus 1/2. Waiting. All right, it took it. Good. So I'm happy that it was allowing the half. I did probably want to combine the 4 and the 9.5, those two coefficients, just because it looks nicer that way. So we got that one. Okay, so that's one of the types of questions. If you're given a focus and a directrix, then you can write the equation of a parabola. The other type of question that I saw was similar to the type that we were doing earlier. If it loads here, waiting for it. There it goes. So find the focus in the directrix and draw the graph. Okay, so this one's actually already written in its focus directrix form. So if I write this down, I can identify those, then I'll just fill them in. If it wasn't already completed, the square wasn't already completed, then you would go ahead and complete it. So I am going to gather the information I know from this. So it's x plus 1 squared, negative 6, y minus 3. So from here, I know that the h value is negative 1. I know that the k value is 3. And I know that 4 times the p-value is negative 6. So if I solve for the p-value by dividing off 4, remember that's 4 times p out front, then p is negative 3/2, or negative 1.5. All right, so the vertex is at negative 1, 3. This is a vertical parabola because the x is squared. So I can find the focus by adding to the y value. So the focus has the same x coordinate. I'm going to add to the y value. So 3 plus negative 1.5 is 1.5. And the directrix is going to be, let's see, we're going to need to subtract 3 minus negative 1.5, so y equals 3 minus negative 1.5 is 4.5. Okay, I'm not sure if it wants decimals or if it wants fractions, so I'm going to try, first of all, the focus in decimal form. It's negative 1, 1.5. If it wants fractions, it'll tell me. Cool, decimal was fine. And then the directrix. The directrix is y equals, and it was 4.5. And then draw the graph. Okay. And so I just want to see what graphing is going to look like for these. So if I grab, it's a vertical parabola, I have the choice between the two vertical parabola and sideways horizontal parabola. This one's a vertical, so I'm going to click my vertex. I don't know if it matters what point I click, so I'm going to, the vertex at, yes it does. It says click the vertex of your parabola. So we found the vertex was negative 1, 3. So negative 1, 3. And then any other point on the parabola. Okay, so I don't have another point on the parabola yet, so I'm going to go to, again, I don't know what it is yet, so I'm just going to go to my equation and I'm going to plug something in. So I'm going to plug in, say, 0 for x, and so this gives us 0 plus 1 squared equals negative 6 times y minus 3, so that's 1 equals negative 6. This one might not be the best choice because I can't divide it by negative 6. So let's try a different one because I want it to be nice and integer. So I'm thinking if I try 5 for x, then I'm going to at least get a 6 in here squared. I'll be able to divide it by negative 6. So I just want some other point. I'm going to try x equals 5. So I'm stopping that process right there. So x equals 5 gives us 5 plus 1 squared equals negative 6 times y minus 3, so that's 36. 5 plus 1 is 6 squared equals negative 6 y minus 3, so if I divide off the negative 6, I have negative 6 equals y minus 3, add 3, I have negative 3 equals y, so that gives me an ordered pair of 5 comma negative 3. Okay, so I needed some other ordered pair that was going to be on the parabola. I can't use my focus or directrix, of course, because they're not on the parabola. So 5, negative 3 is on the parabola. And then I just have some other point and I can save it. All right. So that was necessary, just finding some other point. And again, I was able to choose that point because I knew that I was going to have to, once I saw what I was doing wrong right here, I saw that I was going to have to divide off this negative 6. So I had to try to make this value divisible by negative 6 because it's really hard to graph non-integer values for x. or y. Okay, so that's why I picked that. I picked something 5 plus 1 to give me 6, so that when I squared it, I was divisible by 6. That's how I chose that. All right,